In this class, we will see about drip irrigation components. Basically, all of us know that drip irrigation is an irrigation type in which water is applied as drops at the root zone, and water application is done at frequent time intervals, and water is carried through plastic pipes. So basically, these are all the features of drip irrigation. Apply water by drops at frequent time intervals, do irrigation, and the conveyance is done by plastic pipes. This is what is basically drip irrigation is. The advantages of drip irrigation are obvious. Percolation loss is very less. Unless you give more irrigation intentionally, there is less chance of percolation losses to occur. Conveyance loss is also almost nil. If you arrest all leakages, then there is no conveyance loss. One of the important and notable advantage in drip irrigation is, to some extent, salty soil and in salty soil we can use drip irrigation. In salty water also, if you have water, irrigation water also to be salty, there also one can adopt drip irrigation. And lastly, one advantage, that is the one big advantage, and that is what is driving the popularity of the drip irrigation all around the world, is that fertilizers can be mixed with irrigation water and applied. So this gives a very huge advantage compared with all other irrigation methods. Because of the application of fertilizers with irrigation water, we are able to gain a phenomenal yield. The increase in yield is sometimes even 2 times, 3 times as that of the conventional methods. And this advantage has made the popularity of the drip irrigation around the world to such an extent that now we are in a position to study this kind of courses on drip irrigation. With regard to salinity and drip irrigation, I would like to give some more explanation. In a saline land, when drip irrigation is operated, what happens? If you look here, this is the wetted front. This is the wetted front, and when evaporation from the soil occurs, water along with the salt moves to the surface, and when it gets evaporated at the surface, only water goes. The salt gets deposited over the surface. When drippers are operated at this place or at any place, the salts deposited over the surface then again gets washed towards the periphery. So if you examine the salinity content in a soil, in a drip irrigated field, you will find that all the saline deposits would have got deposited at the periphery. So this does not affect your root zone. The location of the salt deposits is away from the root zone, and this is what makes the drip irrigation unique in using in saline areas. So sometimes in saline areas, if a small rain occurs, say less than 5 millimeter, what will happen? These saline deposits would again get washed and get into the root zone. So strangely, in saline areas in irrigated field, if a very small rain occurs, all the crop would appear with wilt symptoms. It is because of this fact. The saline deposits get washed again into the root zone. So in case of such kind of situations, what the farmer should do is, if rain is very small, then again he has to operate the drip irrigation and wash the root zone and move the saline deposits to the periphery. So only then the crop will again regain its turgidity and things like that. With regard to salty water, why salty water can be used in drip irrigation is because in drip irrigation we maintain the root zone near field capacity, because we do frequent irrigations and the soil moisture level is near field capacity. So the soil solution concentration with the salt does not get increased too much. So because of that fact only, we are able to use to some extent salty water also in the drip irrigation. So the process should be understood well. So we can maintain near field capacity, and that is the reason why we are able to use salty water. So from that itself, you can understand that if the salt water concentration is too high, then drip irrigation cannot also do the help. The concentration of soil solution with the drip irrigation will be equal to the concentration of irrigation water, or it will be slightly more than the irrigation water. What are all the disadvantages with the drip irrigation? As with any technology, it is very, very costly. But nowadays, Government of India helps farmers in terms of subsidy. In Tamil Nadu and all, one gets 100% subsidy. Small and medium farmers are able to get drip irrigation systems free of cost. So the cost difficulty has been lessened by the governments. Otherwise, the other disadvantages are two disadvantages. It's the one disadvantage only. Two reasons. Clogging is the biggest disadvantage with drip irrigation. The drippers and the system gets clogged most of the time. The clogging occurs because of two reasons. One is salt and another is algae. In case of deep groundwaters, the water will contain salt. So when salt water is used, there is possibility of clogging very much. Then one uses river and lake water, then also there is a possibility of clogging because of the algae development. So these are all the two possibilities of clogging. But with nowadays, both clogging, salt clogging as well as algae clogging, both can be removed. And if one maintains the drip irrigation well, one will be able to use the drip irrigation very well and manage these salt clogging and algae clogging difficulties. Now we will see different classification methods of drip irrigation methods. This is one classification. Based on each criteria, the classification is done differently. This with one criteria, this is a classification: point source drip irrigation, line source drip irrigation, and bubblers and microsprinklers. We will see one by one. What point is you know, in the drip irrigation pipes, you have drippers attached to it. When drippers are operated, you get a wetted zones. You see here wetted zones with each dripper. If all these wetted zones do not merge together, if they do not merge together and they are too far, then those kinds of systems are called point source drip irrigation systems. So see here, this is a wetted zone and this is another wetted zone. They do not join together. They are called point sources. Sometimes they can also join together, and all these wetted zones will not join with the adjacent trees wetted zone. Then also this is called the point sources. Next is the line source. In line source, the drippers are so close. Drippers are so close, and mostly the drippers are embedded. Drippers are embedded inside the lateral, and after some time, within a short time, within a half an hour or so, the wetted zone. See here, this is a lateral, and you have drippers placed near each other. And when it is operated within minutes or within a few hours, all these wetted strip will become one single strip. So if wetted zones join together, then that is called as a line source. See here, it's a line source only. It appears. This is a subsurface, not subsurface. It is a surface drip irrigation system. To start with, when it is operating, it appears as though it is a point source. Sometimes all the wetted zones join together and form a single continuous wetted strip. So this is called a line source. When line source, this is another kind of a line source. One line source and another line source placed one near the other. And this line source. When you grow closely grown crops, then one opts for line sources. Next is third is the bubblers and the sprinklers. Bubblers and the microsprinklers. Sprinkler is a separate subject, and microsprinklers are most of the time classified under drip irrigation only. That's a strange way, but it is what is the convention. With bubblers and the microsprinklers, the discharge rate of each emitter will be larger. You will get a kind of a stream like 50 liters per hour, like 150 liters per hour, something like that you will get. So with the bubblers, a single stream comes out for a tree, and since the discharge rate is higher than the infiltration rate, there is possibility of runoff going out. So in order to prevent that, usually bunds are constructed around the tree, and this is also one of the most adopted practice for tree crops, bubblers. And sometimes people use, instead of bubblers, they use microsprinklers. Microsprinklers are very small sprinklers. They appear like a dripper only, little larger than the dripper, and they sprinkle it. When it sprinkles the water over the soil, then the sprinkling rate will be most of the time will be less than the infiltration rate. So in that case, there is no possibility of runoff. So there is no need of bund also in case of bubblers and microsprinklers. This is a microsprinkler in operation. So these you would have seen in many real life situations in gardens and things like that. Mostly microsprinklers are not very much used nowadays for agriculture. It's mostly used in lawns and these kind of places wherein beauty and attraction is needed. But rarely it is also used in agriculture also. Next classification is surface and subsurface drip irrigation. Based on this criterion, if you see, surface drip irrigation will have all your laterals placed above the land. In case of subsurface drip irrigation, laterals are placed below the ground, and the emitters will all be embedded inside. And when laterals and the drippers are operated, the wetting happens inside the soil, and we will study a little more detail about subsurface drip irrigation after a few slides. So at this stage, just know that this is a one classification. If you place laterals on the surface, then it is surface drip irrigation. If you place the laterals along with the drippers below the ground, around 15 to 30 centimeters below the ground, then it is called as subsurface drip irrigation. And components. What are the components? Those are normally used in drip irrigation. Major classification of component is this way. In each of these sections, you will have number of types. So the first component is pump or overhead tank. The pump or overhead tank is needed to give pressure to the water. At the source, you will have at the source of water, you will have a pump or overhead tank. Second is a set of valves. Wherever you need to control water, you obviously need to have valves. And thirdly, you need filters, because you know that drippers are a very fine device. It has a very narrow passage through which water has to come out. So there is the tendency for the water to get clogged. So you need to have filters. There are a number of filters depending on the type of water you use. You need to have different types of filters. We will see all the types of filters. And then already I said with drip irrigation, addition of fertilizer with irrigation water is possible. So that process, addition of fertilizer with irrigation water, is called fertigation. And for fertigation, we need some devices, and there are three types of devices. We will also see how the devices are functioning and how they have to be specified and things like that. And fourthly, we need pipes. We need plastic pipes. We need low density polyethylene pipes, high density polyethylene pipes, and things like that. And what are the information? What are the informations those are needed in pipes with regard to drip irrigation? Also, we will see. And lastly, drippers. It is the heart. It's very important in drip irrigation, drippers. So these are all the components which are needed for drip irrigation to function well. So this is a typical diagram people would have seen in many places. This is a very good diagram which was drawn by a Jain Irrigation System, a company called Jain Irrigation. It's an Indian company, and it has become an international company and one of the renowned international companies in the world. And they have made available this diagram through internet, and this is being used by many trainers around the world. And I would say this is the most used diagram by people around the world. It depicts in a nice fashion with regard to all the components. Those are used in a drip irrigation system. See here, you have a well here, and from the well, pump is used to pump the water, and after the pump, you have a valve called bypass valve. So when you know that all these systems are designed for a specific pressure. If the pressure goes beyond the design pressure, there is possibility of the system getting broken down. So in such situations, if the pump develops pressure beyond the design pressure, how that situation is managed is some amount of water is diverted back to the well, and because of that pressure would get reduced and the system is made safe. In many situations, these kind of large pipe sections with the bypass valve may not be needed at all, because most of the time, this section will be it will be GA only. When it is GA, and most of the time you will have a control valve here, and when you control the water flowing into the system by the control valve itself, there is a possibility of pressure getting reduced. In that case, you don't need to provide this kind of a bypass valve with lots of pipes and things like that. And when you control like that, and there is a possibility for centrifugal pumps and all, there is a and it's not a possibility. In case of most of the centrifugal pumps, the power used will also be less by using, instead of using bypass valve, if you just use the control valve and reduce the discharge, and you reduce the pressure alone, you allow the water to get into the system, then that is very good way, because the power consumed will also be less if you reduce the discharge. If you recall your pump knowledge with regard to the operating characteristics, once again, if you refer through, and in my book also I have explained with these kind of images why this advantage we are able to get if we make use of just a control valve without a bypass valve. But there is one disadvantage also. When you are using a control valve alone at this side, there is a possibility of increasing the pressure at this side. Increasing pressure does not cause any overloading of the motor. Overloading of the motor in the sense no electric overloading of the motor occurs. So the coil burning will not happen. But there is a possibility of your bearings. At the impeller you have a bearing, and that impeller bearing may sometimes possibly cause leaking. So in that case, it is better to use bypass valve itself instead of just GI control valve. Then after bypass valve, you have a non-return valve. What does non-return valve do is it allows water only from one side to the other, from this side to this side. When the pump is shut off, all these are at a higher elevation. The water would immediately tend to go to the lower elevation. So what is done is, with the drip irrigation, fertilizer is injected with the irrigation water. So if fertilizer mixed with irrigation water goes back to your pump, your well, there is possibility of pollution happening inside the water, and most of the time the same well water will be used for domestic and animal rearing purposes and all. So in that kind of situations, then if pollution occurs, then there will be a lot of problems. So in that case, nowadays non-return valve provision at this place is essential nowadays. So after this, you find there are so many blue components. All these blue components are filters. There are 3 filters, and there are 4 or 5 kinds of filters. Those are available in the market. One does not need to install all the filters. Depending on the quality of the water, one may need to use 1 or 2 or 3 filters. So this is the first filter called sand separator. Sand separator is also called hydrocyclone. You would have studied in your processing courses and all about cyclone, the same principle with which this also operates, and the principle of operation you will study in little more detail in the coming slide. But at this stage, Keep in mind that the sand separator just filters the sand. It filters the sand. Then you have a sand filter. Sand filter is different and the sand separator is different. That should be kept in mind. In sand filter, sand is used as a filtering medium to filter the algae. In case of sand separator, there is no filtering medium at all. The process is in such a way that it separates the sand. So that should be kept in mind. Then after that you have a fertilizer injection mechanism. In this case, a Venturi is shown here. How Venturi works and all we will see later on. Instead of Venturi, there can also be other devices called fertilizer tank and fertigation pump can also be used. Then after that, lastly, one filter should be used, because after injection of fertilizer into the irrigation water, there may be possibilities of the impurities coming inside. So that has to be removed, and that is done by this filter. Then after that, all these things are set as a control head, because here is the place where we control the head. Water going in is controlled. The pipe section leading from the control head to the field, this is called main pipe. Then for each field there is an offtake, and this is called submain. Each submain will have a control wall. Usually these pipes are PVC pipes. Main pipe and submain are PVC pipes, and they are buried under the ground. Sometimes you will also find these pipes to be high density polyethylene pipes also. They are little costlier than the PVC pipes, and they can also be buried under the ground. But HDPE pipes can also be placed over the ground, because HDPE pipes do not get affected by the ultraviolet rays in the sunlight. So if one wants to have a overground pipes, if one is able to spend money, one can also go for main and submain high density polyethylene pipes. They are the layout is like this. Then from the submains, lateral pipes are taken. It may be underground or it may be overground. In the laterals, you have drippers. The drippers may be placed over it, or the drippers may also be built inside. And those kind of distinctions we will see in detail later on. And at the ends you see, you find the lateral closed. You find the lateral closed with a lateral stop. And at the end of the submain also, you find there is a valve called flush valve, and it will be above the ground, so that this flush valve can be opened and closed. And there is a reason for this flush valve, and there is a reason why a simple way of closure at the laterals in this way is done. It is because, see here, when pump is shut off, what will happen? All the water in the pipe will get out of the drippers, and a vacuum will get created inside the pipe. When vacuum gets created in the pipe, what will obviously happen is the atmosphere is under pressure. The atmospheric pressure will give an impact. On the pipe, and from the atmosphere, whichever dripper drained first, through which water stopped coming, through which the air will get inside. The air will get inside with a velocity. The drippers are touching on the ground. So when the air gets into the pipes through the drippers, it will take a lot of soil particles along with that. So every time pump is shut off, after vacuum is created, some amount of soil particles will get into the pipes, and that will not be known to the farmer at all. Gradually, the water part, the pipes will get filled with soil particles, and all these soil particles get loaded at the ends. Here. Okay, so those have to be at frequent intervals. Those have to be washed by opening the flush valve. If you open the flush valve for a few minutes, you will get a muddy water. Then after some time, you will get a good water. Then it is an indication that all muddy water, all soil particles have come out. Then you close it. Same way, the soil particles, those are available at these ends, will also be opened, and for at a time maybe 3 or 4 or 5 laterals will be opened, and all the soil particles will be removed, and it is closed. So this is the purpose for which the flush valve is placed here, and easy opening and closing provision is provided at this place. And you find here there is an air valve. Okay, when air valve is placed here, air valve is also is useful in reducing the soil particles getting sucked into the system. So what does the air valve do is, when the pump is shut off, I said the vacuum gets created. When vacuum gets created, through the air valve, air will get inside immediately. When air is able to come through this, and fill the vacuum, there is not much reason for the atmospheric air to get into the dripper and to the lateral pipes. So that's one advantage of air valve. It allows the air, and also when pump is put on, the water has to get filled inside the pipes. So when water gets inside to fill the pipes, the air has to get removed. In that situations, also the air will get away through this. So this is the function of air valve. If you look here, the air valve has it's a simple mechanism. See here, this is a float. This is a cut section. This is a air valve. This is a cut section, and this is a float. And this float will be floating on the water, just floating on the water. It is not fixed with your body. So when the drip irrigation system is functioning, water will push this float to this upper end, and there will not be any connection of atmosphere with the system, and it is closed. So when pressure gets reduced, this float gets dropped down to this place, and there is a connection. Connection occurs from atmosphere to the system, and the air will come inside. Okay, so this is the way it functions. So when system is getting charged with water, also when pump is put on, also the air will escape through this. Because pressure will be lower during that situation. The float will be somewhere here, and the air will come and it will go this way. And placing air valve is an important thing. Only if you understand how air valve works, then only you will place air valve at a proper location. See here, let us assume that you have a ball valve here, and you have a number of submains operating like this. Okay, so let us assume that you are setting up this ball valve to close this. Okay, in that case, this air valve will not be of any use to you at all, because once this valve is closed, then after water comes out, then this air wall will not have any kind of a connection towards it, to this submarine. So in that way, this air wall will help. This air wall will help functioning for only for the main pipe alone. So if you had provided, if one provides an air wall after ball wall, then it is better. And similarly, in main pipe also, where first vacuum will get created, at is at the highest elevated place. So when water keeps draining, this is the place first vacuum will get created. So instead of providing an air wall at this place, if one provides air wall at this place, and this is the right place of providing air wall. Okay, so if one can provide air wall at this place also, more than that, one should have provided air wall at this place. So air wall may appear very, very simple, but its use is very, very important. Its functioning should also be understood very well in order to make use of the air wall in the system to function the irrigation system very well. So see here, wherever the main pipe goes up and falls down, okay, there is a possibility of air or vacuum pockets to get formed. So at every fall, at every rise and fall, an air wall should be provided, or otherwise there is a possibility that because of the atmospheric pressure, the pipe may get broken down at this place. Next is first component is overhead tank. I said in order to give pressure to the irrigation water, we need a pump or overhead tank. The pressure needed for drip irrigation system to function is between 5 meters to 15 meters. Sometimes in some books you will also find 5 meters to 17, 20 like that. The higher boundary depends on what kind of filters you use. And normally if you have around 10 meters of pressure head, one will be able to make the drip irrigation system function very well. 5 meters and all will be very, very low. And for pressurizing the irrigation water at the source, one can provide overhead tank and do the job. But normally it is not recommended. If one farmer has already overhead tank, then one can use it. No issues. But if a farmer gets into drip irrigation system first, it is not recommended to go for overhead tank because it is very, very costly. And if you construct a overhead tank for a height of 15 meters, just imagine 15 meters is somewhere around 50 feet, like 5 floors, and that too for agriculture and all. You cannot have a very small tank like domestic tanks. You need to have a few lakhs liters of tank. So that and all will be very, very costly. And it is not advisable to go for overhead tank. If one has overhead tank, one can very well use it. And there are more disadvantages if one uses overhead tank along with the cost. Is that because most of the overhead tanks will be of less height than these dimensions. So when you have less pressure, there will be clogging problem in the drippers. And when you do design for drip irrigation system also, you need to make use of large diameter pipes because within shorter time you have to carry larger flow rate. So in that situation, you may have to make use of large diameter pipes. So when you go for large diameter pipes, then it becomes costly also. So it is always recommended to go for a pump. Depending on the pressure need, one can select any kind of a pump, and the pressure can be very easily adjusted with pumps. And the advantages, as I said, in relation to the overhead tank, with the pump you will have design diameter of the pipes will be less, and you will be able to get more pressure. So the clogging problem will also be more. Clogging problem will also be very, very less. With regard to types of pumps, all kinds of pumps can be used except the airlift pumps. Because airlift pumps uses compressed air to pump the water, and you will not get a continuous pressurized water with the airlift pumps. So airlift pumps cannot be used for adoption of drip irrigation systems. Otherwise, the submersible pumps, jet pumps, centrifugal pumps, all pumps can be used. This is about pumps. And next is filters. The function of the filter is obvious. The function of the filters is to remove impurities and to prevent clogging. So that is the function, and the criteria of design of filters criterion is that all particles larger than 0.075 mm should be removed. So this is a thumb rule people use, and all particles greater than 1/10 diameter of flow passage in rippers. All particles greater than 1/10 diameter of flow passage in rippers should be removed. This is how filters are designed. Filters are specified by the size of the opening. By the size of the opening in terms of microns, it is specified, and also with the discharge rate it can handle. So these are all the two things: diameter of flow passage inside the filters and what is the flow rate it can handle. These are the two specifications based on which one should make purchase with regard to the filters. I said hydrocyclone filter. Now we will see how an hydrocyclone filter functions. The hydrocyclone filter has you see here, there is a metallic tank. A metallic tank with a tapered conical portion, and it has a collection tank at this place. And water enters at the periphery. It does not enter into the tank straight radially. Water does not go. At the sides it goes. Just see, it makes a rotation. When water plus sand, when water contains sand, makes a rotation. What happens is the sand particles have a higher specific gravity. So when water particle has a lower specific gravity, so the centrifugal force that is acting on water relative to sand particles will be on water. The centrifugal force will be less, and on the sand particles it will be more. Mr omega squared. The mass of sand particles is more, so the centrifugal force acting on the sand particles will be more. So since the centrifugal force is more, then they are thrown to the periphery. And during the rotation process, it hits on the walls with the rotation. It loses its energy, and all the sand particles get collected at the bottom in the sand collector, and good water goes out. There is no filtering medium in the hydrocyclone. That should be kept in mind. The water is made to rotate. This is what is the same kind of a cyclone you would have also studied in your processing courses for removal of chaff from your paddy, wheat processing and all. So this is how a hydrocyclone works. So hydrocyclone is used for separating the sand. Next is the disc filter. If you look at the disc filter, if you look at the disc filter, there are number of grooved rough discs, hundreds of discs. This is the filtering medium, and they are placed something like this, and they are tightened. This is a filtering medium, and when this is placed inside a container, and how water goes in between. Water goes in between the disc. It radially goes this way. And when water goes in between the disc, the flow passage, the opening shape, it keeps on varying along the way. Look at this GIF image. You see how this is how the shape of the flow passage gets changed. When shape of the flow passage gets changed, there is a lot of turbulence and change of direction, which causes the water to shed down its impurities, and the impurities gets trapped in between the discs, and it is this is how the disc filter functions. Next is screen filter. This is a good old filter, and this does not have any big thing. It has a simple screen. See here, it is a simple screen through which water passes, and water gets filtered, and good water goes in. The materials that clog the system gets deposited over the surface, and periodically it has to be removed and cleaned. And there are also provisions for automatic cleaning by backwashing and all. And normally the mesh size used for screen filters is 0.07 mm, or in microns it is called as 70 microns. And lastly, sand filter. This is one of the very important, very good filter and costly filter. When one makes use of river water or lake water, you will have a lot of impurities, organic impurities and algae. So in that case, sand filter becomes inevitable. How this functions is, it has a huge tank, something like 30 to 30 liters, 60 liters, 100 liters tank, very huge tank with a very thick outer wall, because the hoops stress, when you have a larger tank, the hoops stress will be very high. So in order to withstand such high pressures, with the same pressure, the stress will be more. Stress on the material will be more, and that's the reason why you have a. If you look at these tanks, one will not be able to lift this tank at all. Maybe 2 or 3 or 4 persons may be needed to lift the tank. That is the reason why this tank is very costly. How it functions is, within the tank you place the sand. Mostly synthetic sand is adopted a uniform size of sand particles are placed. You should not use graded sand. If you are using graded sand, then filtering will get affected. You should use uniform size of the sand, and the raw water comes in and gets filtered, passes through it's a cut section. It's a cut section shown here. It gets filtered and it gets collected, and good water goes. So one of the very big difficulties with it's a very good filter, of course, but one of the very big difficulties with sand filter is when it gets clogged. After some time, it gets clogged. When it gets clogged, washing becomes very difficult. One has to take out all the sand and wash it. It becomes very difficult. So all sand filters have to be provided with an automatic back washing facility. See here you have a tank here. In back washing, what happens is, see here, water goes, and water goes to the bottom first. then moves up and comes. So it is during backwashing. It is not during the normal process of filtering water. It is during backwashing. Water is made to pass from bottom up, and the waste is collected and it is washed. And this is the way the backwash system works in sand filter. In sand filters, you will find lots of valves to do this kind of backwash process. Now we will see fertilizer injectors. I said there are three kinds of fertilizer injectors. One is called Venturi assembly, and the second is called fertilizer tank, and the third is fertilizer injection pump. We will see each one by one how each accessory functions. Venturi assembly. Venturi assembly has a simple mechanism. See here, this is a main pipe. This you make a bypass, and this is a Venturi. This is a Venturi. See here, a Venturi has a simple construction. Water is made to pass through a narrow section. Then expansion is done for a larger distance, because the expansion, you can have the contraction can be within a smaller distance. It is allowed. But expansion cannot be done in a smaller distance. If you do expansion at a smaller distance, then there will be a lot of turbulence and it will not function well. So you will find the expansion section in a Venturi to be a larger thing, and in main pipe you have a valve, and in bypass also you have a valve. And if this is partially closed and if this is opened, you will get water supply through this. Then water goes through a narrow section. Obviously, as we have already discussed, the pressure at the narrow section will drop down. The drop down level of the pressure, if it is lower than the atmospheric pressure, then there is a tendency for the atmosphere to get into this place. So if you place your fertilizer mixed water down here, then atmosphere will give pressure over this place, and this will cause the fertilizer mixed irrigation water to get mixed with your irrigation water and passes through your irrigation water. This is the way it functions. It's a nice accessory used for fertilizer injection in drip irrigation system. It's very less cost. It's a good system. You will get a continuously same concentration of fertilizer in the irrigation water. And only one disadvantage it has is, if you make use of this system in the drip irrigation system, this will cause a lot of pressure energy loss because of contraction and expansion. To a level of 3 meters to 5 meters of pressure loss will happen because of this system. So if already you have a pressure issue in your pump and all, better not to make use of Venturi. Venturi adoption will be difficult. In such kind of a situation, one may have to adopt another system called accessory called fertilizer tank. Fertilizer tank is a simple mechanism. See here, this is a main pipe. You have a valve, and here also there is a bypass. And just downstream side of the valve there is an octave, and it goes into a tank. This is also a very heavy tank. You just cannot use a normal tank because it is operated under pressure, and it will also have a very thick material, and it is also costly, around 5,000 rupees. It will be costing. Smaller size tanks around 30 liters and all will be costing around 5,000 rupees, because it's very huge, heavy tank. And fertilizer is placed inside this fertilizer tank, and when water from here goes in, it gets dissolved, and the fertilizer mixed water will come out and it joins at the other side of the well, at the upstream side of the or the downstream side of the well, and the fertilizer mixed irrigation water keeps going. So whatever be the pressure, if the system is functioning, and it will function. So pressure issues it does not have, but it is costlier than the Venturi. And the flow through the fertigation tank can be adjusted by this well. If you fully close, all water has to go this way. Partially close, then some amount of water will go this way and some amount will go this way. And depending on the pressure difference, depending on what kind of pressure difference, what amount of pressure difference will cause what rate of flow can be obtained from the catalog of each company, and that information can be used in operation of the fertigation tank. And normally they are designed in such a way that if 4 to 10 times volume of the fertilizer tank water is passed through this tank, all fertilizers would get into your system. So that should be kept in mind. And you will not be able to, one small disadvantage is that you will not be able to get a fertilizer concentration in the irrigation water will be constant, because to start with you will have a higher concentration. After some time you will get lower and lower. So the fertilizer concentration in the irrigation water may not be constant. Lastly, the fertilizer injection pump. Fertilizer injection pump, it is costly, more than 10,000, 20,000, 30,000, 40,000, 20,000, like that. There are so many pumps depending on the sophistication of the pump. They are available in the market. And see here, all pumps, most of them, they have a, this also, though this is called as pump, this does not need any external energy for it to operate. This does not need any external energy. The energy needed for operation of this pump is also obtained from your irrigation water pressure itself. See here, this is the main line and this is a bypass line. This is the heart of the pumping system, and it has this a cut section. This is a cut section in which you find here there is a piston. This piston is operated by this incoming water. By movement of the piston, it causes suction. It causes suction at this end, and the fertilizer fertigation solution, when suction is caused, it is sucked in and once again pumped out, and it gets mixed with your irrigation water and it goes. So with this pump, one will be able to get a precise concentration of fertilizers. So in greenhouses, in export quality and all, one may need to maintain the fertilizer concentration to such an extent that it should be very, very precise. In that kind of situations, only the fertilizer injection pumps are used. Otherwise, the other two systems themselves are much more sufficient. So with that, I conclude this class. In next class, we will look into the other things like pipes, drippers, and things like that. So with that, I conclude this class. Thank you.